Hello, I'm Adam Erb. It's been 1 month since my last confession, and I'm here to admit my sins that, yes, it's true, I wrote an app without any layouts, fragments, or activities. So usually when I tell people this, the response is immediately kind of a what the hell type of response. Why would you do this? So the context is I started with a company called eBlock. I actually moved to Toronto about 3 years ago to start this app from scratch. I originally wrote it using completely traditional methods and best practices, XML, all that stuff, activities, fragments. But the project did have some unique challenges. It was like kind of a live auction kind of gamified application, so there were also regular real-time updates. It had very kind of custom, heavy animations, and the designs were non-negotiable. Basically, we were given PSDs. They weren't specifically designed for Android or for iOS. They were just kind of, here's a PSD, like this has to look pixel perfect, and there's no wiggle room. So I built it out using traditional practices. The original app suffered from a couple of issues. It just had kind of poor performance. It was pretty janky in areas. I was having a really hard time just meeting these kind of pixel perfect requirements. And it was a very stateful app where like a lot of views, depending on the entity state, had to display in different ways. So I found kind of exploding number of distinct views. Poor view reuse in general. And then, like, since it was multi-activity, I found I was having a lot of frustration propagating events. So the process is originally what this talk was about. Was kind of like how I got from there to here. But as I was writing it, I was kind of boring myself and felt a little bit defensive. So what I've actually decided to do is kind of focus more on the end result and kind of break down the process just into this slide. But it was kind of an experimental iterative process, and it wasn't all or nothing by any means. It's not like I wrote this thing and I was like, oh, it's terrible, I'm rewriting it. I kind of picked out some of the more problematic views and started experimenting and kind of changing them in different ways. And what I found actually was when I kind of, as I kind of converged on this one kind of approach, I actually found that these were the views that I wanted to work more in. Like these were the views that felt the most maintainable, the most clean. So slowly over the period of a couple of years, kind of the whole app just slowly migrated to this kind of technique. So the end result is that the app has basically zero XML in it. There's layout or drawables. I don't really use any higher level constraints like relative layout or constraint layout. It's done almost exclusively through ViewGroup on layout on measure methods. No fragments. Basically, ViewGroups act as containers. And no activities as defined by The Simpsons, like no homers. One is allowed, but multiple are not. So there actually is an activity. That was kind of a clickbaity headline. And as a result, I do probably the craziest part is I do manual backstack management. Since there's no activities or fragments, I manually manage the backstack. So from this point on, I'm just going to jump into the project, into some of the code and what the output looks like. I just encourage all of you for like 10 minutes just to kind of unlearn, everything you know. And if you just keep an open mind and kind of look at some of the perks of this approach, you might find it actually kind of interesting. So we're not using XML, so we have to declare our views manually. You typically override view or view group. In order to create children views, you declare them in line in your class declarations. So one kind of useful aspect of this is that you can now inline your kind of event handling with the style declarations, like you're using a full language, so you no longer have to kind of separate style, and you can kind of set like, oh, this is like font, this is my own click, this is my own touch. Yeah, so you create these manually and add them to the view group as you go. One of the most interesting, and I think kind of the crux of this actually, is that you can grab references to these views as you create them. And what that means is that find view by ID is effectively deprecated. You don't need it anymore. You grab references to all the views you need as you create them. And now you have a very cheap way of fetching these things. So that is a bonus in a way, in several ways, but one of the most significant is recycler views, right? Like recycler views, view holder was introduced as a kind of as a optimization so that you're not constantly parsing your XML, find view by ID, like kind of going through the whole hierarchy and finding the view you want and grabbing references and storing in the view holder. You don't need that anymore because your views have references to the sub-views that they're interested in. And you can basically just bind to those directly. So if you kind of combine this with like some generic wrapper, you can get a recycler view adapter that basically just takes in a constructor builder and an onBind function, and that's all you need. And it's pretty fast, and it's very clean and simple. And like what you basically end up with is like kind of nice, clean recycler views. It's like a whole lot less code than you typically need otherwise. So the other kind of benefit of doing stuff programmatically is then that ViewGroups are, of course, a language of dynamic, and you can build them up dynamically. So if there's a stateful view you have, you can build up and add components as you go, and you don't have to suffer the pain of a heavy initialization cost. If anybody's created a layout where you then set the view states to gone or to hidden, that's not always the best because you have to initialize this view basically just so that you're hiding it. Using this approach, you can set up views so that they're only added to the hierarchy as you need them programmatically. So this is really good with like stateful animations. Like in this case here, when you click bid, like these views aren't actually instantiated until the user actually clicks the button. So you can kind of avoid some of the heavy penalties of like highly stateful views early on. And then it gets us to layout. So we're not using any higher level layouts. So like, how are we doing this thing? I basically stopped using higher level layouts, maybe with the exception of recycler view. So how you do this is you override ViewGroup and you hook into the onMeasure and onLayout methods. You again grab references to the child views that you already have, and then you call the layout and onMeasure methods on these subviews as you lay stuff out. One of the benefits of this is pretty much all a single pass. There's a lot of assumptions you can make that constraint layouts and relative layouts cannot make because they don't fundamentally know what's in them. I think, yeah, there's a lot of like very unique layout possibilities as well. Like you can do stuff like layout text by its baseline, by the ascent or descent or whatever. So you can do like very specific custom stuff. It's very, very flexible. And then I think my favorite part of it is that your layout logic is basically becomes simple grade school math. You're not like busy trying to debug. Like I can think of many times where it's like, okay, like I set up this relative layout or this constraint layout, and it's supposed to look this way, but it's not for some weird reason. And in this case, you can just hook in a debugger and basically just look at the values, and it's simple grade school math. So it becomes very easy to figure out what's going on if something is not displaying correctly. And then since it's so flexible, view hierarchies become very flat, which is kind of my favorite part. And this makes it easier to think about, and it does have some performance benefits. So for kind of weird, complex views, that can also be good. I use that approach heavily in this here, where you have like tons of like weird custom views. Drawing is also then a lot easier as well. You're already in a subclass view, so you've hooked into onLayout, onMeasure, and you can hook into onDraw or dispatch draw as well. And effectively, you don't need drawables anymore. You can reference your subviews, and you can just hook into the Canvas API and then just kind of annotate them as you need. Drawables still have uses, like if you want to share a drawable, that's fine. But if you ever want to like annotate a view, this is like I feel like a very quick and kind of easy way to just like underline something or highlight something. So it's a little bit more convenient this way for me. Next. The other thing I really like about this approach is that then the life cycles become very, very simple. Like almost everything's a view, so basically the only thing you're worried about anymore is on attached and on detached from window. That's effectively your life cycle. You can hook into additional life cycles as well, but then one of the benefits of having only one activity, is that your activity life cycle effectively becomes your application life cycle, which is something I found very useful. If you have a multi-activity kind of architecture and you go into the background, or if your activity goes in the background, you don't know if that means your app's going into the background or if another activity is about to be spun up. But using this approach, they effectively become one, right? If your activity is going in the background, you can safely assume, okay, my app is going into the background. But then that brings us to the backstack. So there's no activities, there's no fragments, or there's one activity. So how do you get some sort of nested view kind of look and feel? So I did implement a backstack manually. I think one thing that is worth noting is it's really straightforward. This code here is a fully functioning animated backstack implementation. May not be a shock, but backstacks, you can just use a stack and then basically push and pop onto that. I think there's some additional uses of this as well, in that you now have full control. You can inspect what's on your stack. You can recreate it very easily from scratch if you're coming back from background and you're doing a cold start and you want to refresh everything. And then the usage is also very clean, because now you're implementing your views from scratch, or you're instantiating them, and you're pushing them to the backstack. And since you're kind of in control of everything, you can easily pass a callback to your view, and then when it's popped, that lambda gets called. So that's a much nice, for me, I feel that's much nicer and cleaner than kind of okay, checking your on activity result or on fragment result. Instead, it's just kind of more of a functional, direct kind of response. So using that approach, you can get basically things that look you wouldn't really be able to tell that this is not a legitimate kind of backstack implementation. This is fully virtual. This is not using standard Android backstack implementation. So that's kind of the whole thing. Just to kind of wrap up why I do this crazy thing. So I think some of the advantages are flat layouts, which are simpler to think about and execute, and debug. I think a big one is uniformity. You're not thinking anymore about XML layouts and activity fragments, toolbars, dialogues. Everything's kind of a view, and in this way, there's a power in just having one thing to think about. And in this way, there's no context shifting. You're kind of always in the same language. You're always in Java or Kotlin or whatever. It's extremely flexible. What I like, part of the reason I went in this direction was that is that my boss can't give me any PSD, and I can't say oh, I'm not sure if I can do that. It's all the answer is always yes. And your views are now described in a fully featured language. It's not really, you're not in a strange dialect of XML anymore. This is you can take advantage of inheritance, of interfaces, of callbacks, trivial lifecycle management and event handling. API stability is another huge thing. All the APIs I'm using in this case are APIs that have been there from version 1, and they're very unlikely to break, because if they do break, then all of Android will break. This approach is compatible. It's you don't have to go in all or nothing. This plays perfectly fine with views that have kind of the traditional architecture. So yeah, there's no real issues there. Almost done. So the bad and ugly. So there's no WYSIWYG editor, which is what people bring up almost immediately, and it has a pretty steep learning curve. On both these items, I would say that this is not. I found it surprising how quickly it was to kind of get up to speed and actually get younger developers up to speed using this technique as well. You pretty much learn to eyeball stuff and code it out, and you can get it right pretty quickly. And then the learning curve is not as bad as you'd expect. I mean, if you consider yourself a professional, if you can consider yourself a professional programmer, this is not using anything that's beyond any of us. It's relatively straightforward. So that's the end. Thanks for listening to me. Keep in mind that I'm a human being with feelings. Yeah.
you lied me. Like you lied to me. I saw an activity in slide 3. A reference to activity in slide 3.
Yeah, no, sorry. The joke I said early on was that it's no activities. One activity is allowed, but not multiple. It's a bad homework. It's a bad Simpsons joke. Like when Homer's in the. Yep, it is an activity. Yep.
So you use some kind of state machine to control the state of the application and see which views have to show up, which ones have to go away?
I mean, yeah, like that's kind of the backstack implementation I showed you. Like, I mean, that's kind of the only state machine there is. Like, you hook into the back event. When you want to push something to a view, you push it to the backstack, and then if a back event happens, you check that stack. If it's empty, you treat the event normally, but if it's not empty, then you pop the view and animate it. So that's kind of the only state machine that there is. Yeah. Yep.
Are you familiar with like more modern JavaScript frameworks like the MVVM paradigm? Because it sounds almost exactly like what a lot of JavaScript stuff is doing. So like, I follow up, like, did you make this up or did you find this somewhere?
I made this up, but I think that is kind of an interesting. That is something I actually wanted to bring up in the talk, which is that it seems like a lot of the Android world seems to think that this is crazy, but like JavaScript is actually kind of going in this direction. Like this kind of what React is like becoming a more programmatic kind of approach.
Or even like React Native. Like I think it also uses only a single activity. Like for the default instantiation of it, like you can add more, but it's kind of a.
I mean, I use React Native, but I would believe that.
So like that's kind of their paradigm of like how they get around like wanting to do an MVVM architecture. So.
Yeah, I don't know if it's strictly MVVM, but the definition of that seems to change with the person you ask.
Yeah.
But it's
You mentioned in one of the slides about you deal with styles programmatically, and Kotlin makes it a little bit nicer. Can you talk a bit about how you do styles?
About how I do
styles.
Styles, like I mean like. Do you mean?
I mean, like, how do you ensure like consistency of, say, color across the widgets, or text size or something?
Yeah, I mean that's kind of interesting. So like you can define your resources like inline, like since you're just on language, they're basically just properties. Since you're in a language, you can subclass and you can have interfaces. Well, more just subclass. So like. An example of having like a specific style of button, like we have like an e-block button which has like kind of default behaviors. You can tweak them, but I guess styling kind of comes naturally through inheritance. I guess that's kind of how I do things. Yeah. Yep.
Are you using Kotlin like a DSL or?
No, like so. I mean,
use the UI. You can use it.
Yeah, because if you want to do stuff programmatically, like Anko is an option for sure, and that would be more of a declarative API.
In your own UIs, because I believe you already have your own custom widgets, and if you use DSL, it will be more nicer.
Yeah, I mean, Anko is definitely an option that I kind of explored a bit. I think the fundamental drive behind the thing was like stripping away layers, like kind of use as little as possible. Actually, one of the benefits of that I should mention is that app is like 3 megabytes in the App Store. Like it is, it's very you can have a very minimal kind of footprint. It uses almost no dependencies. I wasn't using any libraries other than like it uses Kotlin, of course. It uses Picasso, but like it's pretty minimal. Yep.
So do you have multiple presenters? I assume you do. Because like if I want to launch something that's equivalent of an activity here, something that's the same as an activity here, like in a normal app, I would send an intent, launch an activity, right? And I might have a presenter there, a presenter and a view there.
Yeah.
So what do you have here?
So like, it's like a loosely like model view controller or model view. I mean, all that stuff is just like the definition of that. I never know which is which, but we use kind of like a loose concept like that. Like there's no activities, there's no intents. So typically what you do is you pass in, typically what I do is I like either instantiate a controller inside the custom view or pass it in as a constructor argument. It's one of those two things. Yeah.
Do you have deep links or?
Do we have deep links? No, that's not something. It's not really a requirement we had. So yeah, I don't see any reason it wouldn't play well with that. But no, we don't have deep links. All right.
Yeah, cool.